statistics, we often make decisions based on data. But how do we measure the strength of evidence against a claim? The p-value is one of the most widely used tools for this purpose. Today, let us unpack what a p-value truly represents and what it does not. Good morning once again. I am Dr. K. Muralidharan, Professor of Statistics, working with Maharaja Sayajirao University of Baroda, and is also an internationally certified Six Sigma Master Black Belt and a quality trainer. Okay, let's recall. Hypothesis is a conjecture or an assumption or a proposition for the occurrence of a specified phenomenon. It's a statement about a population model, or it's a probability distribution such as binomial, Poisson, normal, and so on. Okay, many often it talks about parameters specified under a particular model. So the parameter could be anything like mean, median, standard deviation, proportions, and so on. So hypothesis is being tested is called the null hypothesis and is usually denoted by H naught, and which is tested against that is called the alternative hypothesis. So for every testing procedure, we specify a significance level alpha, which is nothing but the probability of rejecting H naught when H naught is true. So, and the p-value is that where we have almost every time compare with this value of alpha, and if p less than alpha, we reject H naught. So let us look at a simple example. You have H naught, the new drug has no effect against H1 drug improves recovery, or it says that new drug has some effect. This is how you specify H naught. H naught should be a null statement or neutral statement. It should be indiscriminate, no partiality between the statements and so on. So alpha is given as 0.05. Suppose the computer value is given as 0.008, and when you compare 0.008 with 0.05, we can see that it is less, and therefore we reject H naught. So what is the meaning of this? If the drug truly had no effect, there is less than 1% chance that we would have seen results this extreme. So the data provide strong evidence that the drug does have some effect. So let us understand some perceptions about p-value. A p-value is a measure of how much evidence we have against the null hypothesis. So a general rule is that for small p-value, there is a strong evidence, and for large p-value, we say there is no evidence against the null hypothesis. So numerically speaking, p-value is actually a number between 0 and 1. And statistically speaking, it is actually a measure of evidence against H0, which is again a value between 0 and 1. And philosophically speaking, it reflects our understanding and decision uncertainty and decision threshold, but not the truth or falsity. Okay, so let us understand the computation first, then we will get into the deeper part of it. So suppose we have the calculator value of the standardized test statistics for a given situation, for a given process, for a given circumstance, and the null hypothesis given as Tx, which is equal to C. Then the p-value is defined as p-value is equal to probability of Tx less than equal to C if that's a left tail test, probability that Tx greater than equal to C for a right tail test, and 2 times probability of Tx less than equal to C, or 2 times probability of Tx greater than equal to C if the test is two-sided test. So for a significance of the test, p-value is compared with the pre-specified values like 0.01, 0.05, and 0.10 like that. They are called often significance levels. However, one should not confuse with these values with the value of alpha, which you may say level of significance and is defined as probability of type 1 error. We have already seen that. Okay, so let us move on. So we have a simple example. It's not mu less than or equal to 100 is tested against H1 mu greater than 100. And some sample informations are also given. Sample size is given 20 and X bar is 105. So let us compute these test strategies as well as the p-value for different standard deviation. So we will understand whether by changing the standard deviation, will there be any effect on p-value? Naturally, and that's what it's going to be. So the test statistics, definitely it's a normal population based test. So we use X bar minus mu naught by sigma by root with all these sample values. So let us compute the p-value for the sigma equal to 5. The first case, the p-value is coming out to be 3.8727 multiplied by 10 raised to minus is very, very small number. Okay, it's very, very small. So in the second case, sigma is equal to 10, the p-value is coming out to be 0.0127, and in the third case, it's coming out to be 0.0680, slightly larger than 0.01. So here you can say probability is a probability value, actually speaking. Okay, so naturally the question comes, is there any convention? So generally there is a convention. Most of the software also does that job. So if p-value is less than or equal to 0.05, the observed difference is significant. Similarly, if it is less than or equal to 0.01, the observed difference becomes highly significant. And if it is less than 0.001, it becomes very highly significant, and so on. That's how we interpret the research test procedure. And naturally, if it is greater than 0.10, the observed difference becomes very, not significant at all. So for instance, suppose we have the one-sided test that to a left tail test, and that set value is coming out to be minus 1.9, and the p-value is given as 0.0287, which is from, by comparing the normal distribution table, you can get this value. So you can see that p-value 0.027 is much less than 0.05, so we can say that the test is significant. So roughly that the p-value is 0.0287. That means 33%. That means that there is only a 3% chance of seeing a significant difference in the hypothesized value and the actual value. That means they are equal. So that's how you go and interpret the value. So let us have a deeper look. So from a statistical perspective, purely, let us understand, well, again, the decision rule, C less than K. K is a threshold like 0.01, 0.05, like that. And suppose you have computed for a given test procedure, the p-value is coming out to be 0.049, 0.017, and 0.002 respectively, and which are all less than 0.05. So naturally, we have to reject the hypothesis. So obviously, the decision of rejection of the null hypothesis is more justified in the third case, because that is much less than 0.05 than the first two, and the second case than the first one. Okay, because the smaller the p-value, the more evidence we have against H naught. So p-value is a measure of how much evidence we have against the true null hypothesis. So if p-value is too small, then there is a strong evidence against the null hypothesis, while a large value means little or no evidence against the null hypothesis. So here at this point, we have to be a little careful about the interpretation of p-value. So it does not mean that the large p-value always favor the null hypothesis. So p-value shows the strength of the decision of the rejection of H naught. So if p-value, which is equal to 0.05949, which is very close to 0.05 naturally, but however it is still less than that. So we may say that the inference, you will have to take a wise decision, saying that further study may be necessary before rejecting the null hypothesis. So this is where the statisticians to take care of it. Even business people and consultants should also be careful while interpreting the p-value. So let us understand some more concept. So a p-value carries meaning about the evidence for your data providing regarding the hypothesis. So if the number, say for example 0.03, is simply the quantitative expression of that probability, but its interpretation depends on many aspects like context of study, null and alternative hypothesis, test statistics, and sample size and experimental design. So don't take it for granted. So the computation of p-value involves, statistically speaking, all these components. So the p-value is the bridge between data and the decision. So we all work with data. So how do you connect that data to the decision which you are going to make further? So there it comes the p-value importance of that. So let's see some examples based on set test. So here is a simple test for me. So the context is given. So the calculation is also shown on the right side. So the problem is about testing an alternative, a left tail test actually. So mu is less than 130. So the test statistics value is coming out to be minus 2.16, and the critical value correspond to alpha is equal to 0.05 is minus 1.65, which is less than the 0.05. So it's significant. So test is significant. So let's look at the graphically how it is. So here is the area of region where it is rejected. The p-value is falling under the rejection region. So the rest of the part is the acceptance region. So for a significant test, because that we have already decided to reject the hypothesis since the computed value is less than 0.05. So therefore we say that it's a significant test. In that case, what you need to consider is the p-value may be treated as the lowest level at which the hypothesis is rejected. So here is another example where we will see that it's a test is going to be non-significant. So it's a test is based on a proportion. Context is given. So you are comparing two different manufacturing processes, pharmaceutical manufacturing processes, and details are given, samples informations are given, size N1 and N2 is also given, proportions, different proportions. So you are deciding to test H0 P1 equal to P2 against P1 not equal to P2 under the alternative. So the set calculator value is coming out to be 1.04. And for alpha is equal to 0.05, set alpha by 2 is a two-tailed test. So you need to consider alpha by 2. For two in the regions, you will have rejection. So set is alpha by 2 is 1.96. So you can see that is absolute set calculator value is less than set alpha by 2. And therefore, we do not reject. And therefore, we say it's a non-significant. So here is the diagrammatic presentation. You can see that that p-value comes under the acceptance region. So for a non-significant test, you can always consider p-value as the highest level at which the hypothesis is rejected. So let's look at a test based on F test. So here is an example where we are comparing two different stock prices. The variability is compared as such. So you can see the sample sizes are equal here. Alpha is given to be 0.10 and you are testing H0 sigma 1 square is equal to sigma 2 square against H1 sigma 1 square not equal to sigma 2 square. The test status is given as F calculator value is actually S1 square divided by S2 square, which follows F distribution with the V1 nu 2 and alpha by 2 as the critical value. Okay, so this is actually a two-tailed test again. So this is the complete region of acceptance and rejection. So you can see that P is falling under the acceptance region. So it's a non-significant test once again. So the P value is the highest level at which the hypothesis is rejected. Okay, so actually there are a lot of aspects we have already said that many components are going to be significant while computing the p-value. So one such thing is the sample size. So the answer is very simple. It is CS. Sample size always affect p-value. Okay, so let's see some examples. So the here again is a matter of testing of two means against not equal to, and the difference is given as something like 6 points in some student scores or something like that. Okay, so sample sizes are treated differently, 5, 10, 30 like that. So we'll compute the test set which is shown on the left side. So here is the computation of p-value correspond to different sample size. So n1 and the first two samples are equal to 5. So the p-value is coming out with 0.045, which is very close to 0.05. But still, we have to reject because 0.05 is less than 0.05. So marginal evidence can be seen against the H0. Second case, the p-value is coming out to 0.0038. So there is a marginal difference. So between, when you compare with 0.05, so the test is strong. There is a strong evidence at 0.05 level. So for the third case, the value is also very, very strong because they're much, much less than that. So p-value depends not only on the difference between groups, but also on how precisely we have estimated that difference, which is coming from different groups. So you have to take a care about the group size, etc. Okay, so p-value from a statistical perspective. So the main focus of this presentation is to see that how statistics actually plays in the computation of R. Many of them people take it for granted. The computation of p-value when the software gives some value, so people directly accept it and decide and take the policy decisions. So make sure that p is a number probability value and quantifies evidence against H0. So a small p-value only means that the observed data are unlikely under H0. It's not coming from H0. It does not prove that alternative hypothesis is true. So or does it tell you whether the effects is large or practically meaningful? So the p-value depends heavily on sample size. A very large sample can even give it, even small p-value, even small sample can even give large effects that can also go without a significance as well as significance. So always interpret p-value alongside the effect size and confidence intervals. Therefore, the use of p-value should be validated through strict statistical principles, but with a caution. The p-value does not measure probability of a hypothesis. It's not even the probability that under H0 is true or false. So many often this is false, a kind of a misinterpretation, misunderstanding between in the community of statistics and social science research So they always treat p-value as the probability of H naught rejecting H naught, a true hypothesis, but it is not. It's actually a probability value. It's compared with the probability of rejecting H naught when H naught is true. That is alpha. So it's the probability of observing your data given H naught, not the other way. So absence of evidence is not the evidence of absence. So be careful about it. Okay, guys. So from medical trials to business analytics, decisions are made every day using p-values. So understanding the role of p-values in statistical inference is extremely important. Okay, so please stay tuned for more videos, such videos on my channel, Elucidation and Interpretation. Thank you very much.